Hey guys, very good evening everyone and welcome to another session by 360DigiTMG. We are in the process of learning about the domain analytics and in this particular session that I'm conducting, I'm talking about capital market analysis. So since the last few days we have been discussing about what is capital market and you know how can we do the data pre-processing. We talked about EDA. We talked about k-means clustering and we talked about KMM. We also talked about what is project management methodology. So today we are going to discuss about what is decision tree and how can we utilize the decision tree algorithm for our capital market domain. When we talk about classification, guys, classification is a two-step process. Learning a step and predicting the steps. In the machine learning, or rather in the learning step, the model is developed based on the given training data. In the prediction step, so let me jot it down for you. So we are having two steps in your classification. One is your learning step, and one is your prediction step. When we talk about your learning step, the model is developed based on the given training data. Whereas when we talk about prediction step, the model is used to predict the response for the given data. Now, when we talk about decision tree is one of the easiest and the most popular classification algorithms to understand and interpret. And the beauty of this is that you exactly know the exact reason of why a particular thing is happening. That if there is a person X and he is buying a laptop, not buying. If he buys a laptop, you will exactly know why he is buying the laptop. What are the various criteria. If he's not buying a laptop, you will be exactly knowing what are the various criteria that this person is not buying the laptop. So decision tree is one of the easiest and the most popular classification algorithm that we have. Besides your classification, decision tree can be also used for regression problems, but mostly it is preferred for solving your classification problem. It is a tree-like structure. When we talk about tree, so tree will be having leaf, branch, and root. When we talk about decision tree, here we are having the root, branch, and leaf node. Decision tree is a tree structured classifier where internal nodes represents, even before we discuss all these things, let me quickly discuss more about this. The goal of the decision tree is to create a training model that can use to predict the class or the value of a target value by learning simple decision rules inferred from your prior data, you can say, or your training data. So there are some terminologies, or even before we discuss terminology. In decision tree, internal nodes represents the features of the dataset. Branches represents the decision rules, and each leaf node represents the outcome. Right? It is called a decision tree because it is similar to a tree. It starts with the root node. As I was telling you, here we are starting with the root, which expands into branch, and then you have your leaf. Decision tree simply asks a question, and based on the answer yes or no, it further splits the tree into subtrees. There are various types of decision trees. When we talk about various types of, we are actually having two types. One is categorical variable decision tree, and one is a continuous variable decision tree. When you talk about categorical variable decision tree which has a categorical target variable, then it is called as a categorical variable. When the target variable is continuous, it is called as a continuous variable decision. Suppose we have to predict whether a customer will pay his renewal premium for your, say Netflix. Here we know that significant customers, insignificant, one thing that we know that the income of the customers is a significant variable. But when we talk about some companies, say Netflix or insurance company, now these companies does not have the income detail for all the customers, right? So as we know that this is a very important variable when we talk about your salary, then we can build a decision tree to predict customer income based on the occupation, product, and various other variables. In this cases, we are predicting the variable of your continuous variables. Another thing, in the decision tree, for predicting the class of a given dataset, the algorithm starts from the root node of the tree. This algorithm compares the values of the root attribute with the record attribute, that is your real dataset. And based on the comparison, follows the branches and jumps to the next one. When we deal with the decision tree, it usually mimics the human thinking capability while making a decision, so it is easy to understand. The logic behind a decision tree can be easily understood because it shows a tree-like structure, right? So decision tree, as we know, is a tree structure classifier where internal nodes represent the features of a dataset, branches are representing the decision roots, and each leaf represents the outcome. So there are a few terminologies that you should be aware of when you are dealing with your decision. The first one is your root node. When we talk about root node, it represents the entire population or sample, and this is further getting divided into two or more homogeneous sets. Then you have something called as split. Here the splitting is happening. Here the splitting is happening. The splitting is happening. What is a split? A splitting is a process of dividing a node into two or more subnodes. So here we have a node and it is getting divided into two nodes. Here we have a node, it is getting splitted or divided into two other subnodes. That is a split. When a subnode splits into further nodes, then it is called as your decision node. Decision node. You see over here. Another thing that you have is called as your leaf node or your terminal node. Nodes do not split is called as your leaf or the terminal. When the splitting is not possible and the splitting stops at a point, or the node at which the splitting stops, that is called as your leaf node or your terminal. Few other things. Pruning. When we remove subnodes of a decision tree, this process is called as a pruning. Or in another word, it is nothing but the opposite of your split. Your branch or subtree. The subsection of the entire tree is called as a branch or the subtree. And you are also having parent child nodes. A node which is divided into subnodes is called as your parent node. Parent node of a subnodes are called the child of your parent. Decision tree classify the examples by sorting them down the tree from the root to some leaf or the terminal nodes, with the leaf terminal node providing the classification of the example. Each node in the tree acts as a test case for some attribute, and each edge descending from the node corresponds to the possible answers to the test cases. So this process is actually recursive in nature, you can say, and is repeated for every subtree rooted at a new node. Okay. When we want to talk about, downsizing or expanding, when we want to talk about succession planning or changing price models or the product offerings, relocating outreach, these are the various cases where we can utilize our decision. There are some assumptions also associated with your decision tree. In the beginning, the whole training data set is considered as a root. Feature values are preferred to be categorical. And if the values are continuous, then they are discretized prior to building the model. Third, Records are distributed recursively on the basis of attribute values. Fourth, order to placing attributes as root or internal nodes of the tree is done by using some statistical approach. There should be, some rational behind it. You cannot just randomly do the things, right? Okay. When you deal with your decision tree follows sum of product representation. The sum of representation, sum of a product is known as disjunctive normal sum. For class, every branch from the root of the tree to a leaf node having the same class is your conjunction or product. Conjunction and product of what? Of values. Different branches ending in that class form a disjunction or your sum. The primary challenge in the decision tree, guys, or you can say in a decision tree implementation, is to identify which attribute do we need to consider as the root. Suppose you are having a data set and you are having various variables, say name, age, sex, gender, income. When you are having multiple variables, there is a challenge for you that which of these variables should be chosen as a root node. Handling this to know as the attribute selection, we have different attribute selection measures to identify the attribute, which can be considered as the root node at each element. So here we deal with something called as your, information gain. Or entropy. Let us discuss more about this. Now, decision tree is using multiple algorithms to decide to split a node into two or more subnodes. The creation of subnodes increases the homogeneity of the resultant subnode. In other words, we can say that the purity of the node increases with the respect of your target variable. The decision tree splits the nodes on all the available variables and selects the split which results in most homogeneous subnodes. The algorithm selection is based on the type of the target variable. And on each iteration of the algorithm, it iterates through the very unused attribute of the set and calculate your entropy. and information gain. And then it selects the attribute which has the smallest entropy or the largest information gain. Then the set is splitted by the selected attribute to produce a subset of the data. The algorithm continues to recur on each subset, considering only attributes never selected before. So, if a data set consists of, say, n attributes, then deciding which attribute to place at the root or at different level of the tree as an internal node is a complicated step. So as I was telling you, we are using what? For this, we are using entropy. We use information gain. We use something called as a Gini index, Gini ratio. These are the most in use techniques that we utilize while dealing with your complexity of selecting the root node, you can say. So what will happen is each of these criteria will calculate values for each attribute that you are having. These values are sorted and attributes are placed in tree by following the order. That is, the attribute with a high value is placed at the root. While using information gain as a criterion, we assume attributes to a categorical and for your Gini index, attributes are assumed to be a continuous. When you talk about entropy, entropy is the measure of randomness in the information being processed. The higher the entropy, the harder it is to draw to the conclusions from that information. So like flipping a coin can be an example of an action that provides information that is very random. Right? When you talk about information gain, if I say, morning you switch on the TV and there's a news flashing, sun rises in the east. What is new in that? We all know that sunrise only in the east, so the information gain over here is 0. But if I say that one day you wake up with a bad news that is being flashed on the television, tsunami in Japan, now here you are getting some information, so here information is equal to what? Information gain, or IG, is a statistical measure or statistical property that measures how well a given attribute separates the training examples according to their target classification. Constructing a decision tree is all about finding an attribute that returns the highest information gain and the smallest entropy. Information gain is a decrease in the entropy, or you can say information gain is inversely proportional to your entropy. It computes the difference between the entropy before split and average entropy after split of the data set based on the given attribute value. You have Gini index. You can say that Gini index is a cost function used to evaluate splits in the data set. It is calculated by subtracting the sum of the squared probabilities of each class from 1, and it favors the larger portions or partitions and easy to implement, whereas information gain favors smaller partitions with distinct values. When you talk about Gini index, it works with the categorical variable success or failure. It performs only binary splits. Sorry for that. And your Gini index, it works with the categorical target variables, as I told you, success of failure. Higher value of Gini index implies higher inequality or higher heterogeneity. Gain ratio. Information gain is biased towards the choosing attributes with a large number of values as your root nodes. It means it prefers the attribute with a larger number of distinct values. So these are some, ways through which you can, get help in choosing which attribute you need to choose as your root, because you are having multiple, attributes or the variables in your data set. Another thing that you should be aware of is reduction in variance. Reduction in variance is an algorithm used for continuous target variable, regression problems, if I were to say. This algorithm uses the standard formula of variance to choose to split the data. The split with the lower variance is selected as the criteria to split the population. So first you calculate the variance for each node, then calculate variance for each split as the weighted average for each node variance that you are having. One of the common problems when we talk about your decision tree, especially having a table full of columns, they fit a lot. Sometimes it looks like the tree memorized the whole training data, right? So if there is no limit set on the decision tree, it will give you 100% accuracy on the training data set. Because in the worst case scenario, it will end up making one leap for each observation. Thus, this affects the accuracy when predicting samples that are not part of the training set. Then how to avoid this overfitting? You have two ways. One is your pruning decision tree, and one way is your random forest. Pruning decision tree, when we talk about, the splitting process results in fully grown trees until the stopping criteria are reached. But the fully grown tree is likely to overfit the data, leading to poor accuracy or unseen data. In pruning, you trim off the branches of the tree, that is, remove the decision node starting from the leaf node such that the overall accuracy is not disturbed. This is done by segregating the actual training dataset into two sets, that is, training dataset and validation dataset. Prepare the decision tree using the segregated training dataset, then continue trimming the tree accordingly to optimize the accuracy of your validation data. When you talk about your random forest is an example of ensemble learning, in which we combine multiple machine learning algorithms to obtain better predictive performance. The two key concepts that give it the name random is that random sampling of our training data set when we are building trees, and random subsets of the features considered when we are splitting them. A technique known as bagging is used to create an ensemble of decision trees where multiple training sets are generated with the placement. So what is happening in the bagging technique? A data set is divided into n samples using the randomized sampling. Then using a simple learning algorithm or model is built on these samples. Later, the resultant predictions are combined using voting or averaging in the parallel. Then the question comes that which one is better? linear regression, or your tree-based models? Well, it depends on the kind of problem you are solving. If the relationship between dependent and the independent variable is well approximated by a linear model, then linear regression will outperform your tree-based model. If there is high non-linearity and complex relationship between dependent variables and independent variables, a tree model will outperform a classical regression. If you need to build a model that is easy to explain to people, a decision tree model will always do better than a linear model, because decision tree models are even simpler to interpret when we compare it with a linear regression. Finally, concluding, decision tree has been found out useful in classification and prediction modeling due to the fact that it can have capability to accurately discover hidden relationship between variables. It is capable of removing insignificant attributes within dataset as well. It can handle both continuous and categorical variables. The execution of the decision tree algorithm must be possible without having to scale the data as well. While utilizing the decision tree algorithm, it is not necessary to credit the missing values as well. So now let us quickly discuss about a decision tree modeling that I have done on my Jupyter notebook for you guys. Just give me a moment. Sorry for that, guys. So here I am having a data set from this is the Infosys stock market price prediction from these dates, and I'm having a data set from National Stock Exchange of India Limited, NSE, and I'm using my decision tree classifier over here. I've imported the data set. I'm importing the warnings, warning.filter warnings. I've imported Ignore, importing the required libraries, NumPy, Pandas, and Matplotlib. I'm importing the accuracy score as well. Loading the data set over here, storing it into a variable called as a Infosys. From Infosys, I'm dropping all my missing values. I'm seeing that in Infosys, I want your date, open, high, low, close, adjustment close or below. And when I say Infosys.head, this particular data set that I had in this particular variable will show me my top 5 observation that you can see over here. When I say Infosys.info, it is giving me all information for each and every column that I'm choosing over here. I'm importing my chart studio.plotly as your py. I'm importing plotly.graph underscore objs as geo, so on and so forth over here. And here I'm trying to do the visualization. I've initialized the parameters. Layout is equal to go.layout. Title should be this. On the x-axis, I want date, and title font should be dictionary, family this, so on and so forth. For y-axis, whatever details I needed, I have placed over here. I'm saying Infosys underscore data should be x of Infosys date, and y, you should have your closure, and plot me the figure. Just a moment. Now I'm taking the column Infosys open close, making a new column by taking the values of open and subtracting it by close. The same I am doing for the high and low. Again, the data set that I'm getting, I'm dropping the missing values from there. And I'm taking my open close and high low from the Infosys dataset, storing it into a variable called as X. When I say X dot in ahead, it is going to give me the top 5 observations for my open close and high low, which I got. Now I'm creating a prediction over here. I'm saying in the Infosys where you have your this particular column, shift Infosys adjacent various things, and storing it into a variable called as Y. I'm trying to split the data now, and the splitting percentage I've kept as 70%. I've split that into the training data for X, Y, and testing data as well. And then I'm trying to prepare the model. Here I've used your decision tree classifier as you people can see, and from sklearn that I'm importing the metrics, Pylab inline, Matplotlib inline, and I'm calculating your accuracy underscore train should be the accuracy score for this and accuracy score for Y, so on. So for the training data set, I'm getting the accuracy for 100%. For the testing data set, I'm getting the accuracy for 49%. I'm populating the interactive namespaces from NumPy and Matplotlib, and using that, I'm getting this particular training data. I'm using the model that I created over here on your training data, 100%. Then I'm trying to do the probability also, and I'm printing the probability on your testing data. These are the various probabilities that I get. Here, accuracy of the training model for the Infosys stock market price prediction is about 100%. That means 100%. So for overfitting, we have to do some hyperparameters. So from sklearn, I have imported your standard scaler. I am importing your PCA, principal component analysis, and I'm importing pipeline. I'm saying I want to use a pipeline CLF, decision tree classifier. The values that I get, I'm storing it into pipeline, and then I'm running this pipeline model on your training data. Again, I'm having your score as pipeline score as 1.0, that is 100%. From sklearn.model underscore selection, I'm importing your cross validation score. And I'm using that on the estimator using the pipeline for X and Y. Cross validation I've kept as 10. And I'm getting the accuracy score 0.4390, so on and so forth. And the accuracy I'm getting is 0.496, that is around 49%, plus minus 0.36%. So this is how we can use our decision tree for one of the use cases for our capital market analysis. When we talk about, capital market analysis, firstly, data mining approaches are used to evaluate, you can say, past stock prices and acquire useful knowledge through the calculation of your financial indicators. Transformed data are then classified using your decision to obtain through the application of your artificial intelligence strategies. Decision tree are organized, as you can say, an individual. If we talk about, say, investment point of view, how can we use your, decision tree? An individual, suppose, is making a big decision, such as undertaking a capital project or choosing between two competing ventures. These decisions, which are often depicted with decision notes, are based on the expected outcome of undertaking particular courses of your action. Decision tree is applied for, you can say, for option pricing aspect. For example, the binomial option pricing models uses discrete probabilities to determine the value of an option at expiration. The most basic binomial models assume that the values of the underlying asset will increase or fall based on the calculated probabilities that we just calculated over here. If I were to show you, I calculated the probabilities over here, the probabilities that we calculated. So the most basic binomial models assume that the value of the underlying asset will rise or fall based on the calculated probabilities at the maturity date of the European option. When we are valuing real options such as expansion options and abandonment options, it must be done with the use of decision tree, as the value cannot be determined via some regular formula. Real options represent actual decisions a company may make, such as whether to expand or the contract operation. Suppose there is a company that can purchase a piece of land, and if drilling options are successful, it can cheaply buy additional lands of cost. But if drilling is unsuccessful, the company will not exercise the option and will expire worthless. So these are the various, options where you can use your decision tree. And again, it is, as I said, it is a very one of the easiest model that we have. And the best part is that you exactly know the reason why a particular thing is happening. Although not strictly a decision tree, a binomial tree is constructed in a similar fashion and is used for the similar purposes of determining the impact of fluctuation or the uncertain variables. The upward or the downward movement of the interest rate has a significant impact on the price of the fixed income securities and interest rates, you can say. Binomial trees let the investors accurately evaluate bonds with embedded call and put provision using uncertainty regarding the future interest rates. So guys, the examples that we saw, these provide an overview of the typical assessment which can benefit from using a decision tree. Once all the variables are defined, this decision tree become very complex. And these instruments are, often an essential tool in the investment analysis that we use for managing your decision-making process. So guys, that was all about our decision tree for capital market analysis. So again, a quick recap: decision tree are a non-parametric supervised learning method used for classification and regression, and the goal is to create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. Okay, so guys, that was it about the today's session. Thank you so much for joining. I hope this session was enlightenment for you all. Keep on practicing. Be safe. See you guys tomorrow. Thank you so much, guys.